Hello students, welcome to the final part of organic chemistry. In this session, we will study named reactions, polymers, biomolecules, and applications. These are not just important for exams, but also for understanding how organic chemistry connects to industries and daily life. Let's start with Wirth's reaction. Here, two molecules of alkyl halide react with sodium metal in dry ether. The product is a higher alkane. For example, two molecules of bromoethane react with sodium to form butane and sodium bromide. This reaction is useful for preparing alkanes with even numbers of carbon atoms.
Ma'am, can we prepare methane using Wirth's reaction?
No, methane cannot be prepared by this reaction because we always get a higher alkane by joining two chains. Next is coal-base electrolysis. In this reaction, sodium salt of a carboxylic acid undergoes electrolysis. At the anode, carbon dioxide is released and two alkyl groups join to form an alkane. For example, sodium acetate gives ethane and carbon dioxide. This method is useful for preparing alkanes from acids. Now let's see the Raymer-Tiemann reaction. Phenol reacts with chloroform in the presence of sodium hydroxide. The product is salicylaldehyde, which has an aldehyde group directly attached to the benzene ring. This reaction is important because it introduces a new functional group into the aromatic ring. Next is the Cannizzaro reaction. Certain aldehydes, which do not have an alpha hydrogen atom, undergo a special reaction when treated with a strong base. In this reaction, one molecule of aldehyde is oxidized to a carboxylic acid salt, while another molecule is reduced to an alcohol. For example, formaldehyde gives methanol and sodium formate.
Ma'am, can ketones show Cannizzaro reaction?
No, ketones do not show Cannizzaro reaction. It is limited to aldehydes without alpha hydrogen. The last important named reaction is the Friedel-Crafts reaction. Benzene reacts with alkyl halides or acyl halides in the presence of aluminium chloride catalyst. With alkyl halides, we get alkyl benzene. With acyl halides, we get acyl benzene. This reaction is widely used in the synthesis of aromatic compounds with side chains. Now, let's talk about polymers. The word polymer means many units. They are large molecules formed by repeating smaller units called monomers. Addition polymers are formed when monomers join directly without loss of any small molecule. Examples are polyethylene, formed from ethene; polyvinyl chloride or PVC, formed from vinyl chloride; polystyrene, formed from styrene. These polymers are used in making plastics, pipes, packaging, and containers. Condensation polymers are formed when monomers join with the elimination of small molecules like water or methanol. Examples are nylon, used in ropes and fabrics; terylene, used in making clothes; bakelite, used in switches and handles. So, addition polymers involve no byproducts, while condensation polymers always release a small molecule. Now let's move to biomolecules, the molecules of life. First are carbohydrates. They include sugars like glucose and sucrose and polysaccharides like starch. Their main function is to provide energy. Glucose, for example, is the immediate source of energy in our body. Next are proteins. They are made up of amino acids linked by peptide bonds. Proteins are called the bodybuilding molecules. They are needed for growth, repair, and also act as enzymes and hormones. Examples include keratin in hair and insulin hormone. Then we have lipids. These include fats and oils. Lipids store energy for long-term use and also provide insulation. They are made of glycerol and fatty acids.
Ma'am, Why does the body store energy as fat and not just as carbohydrates?
Excellent question. Fats store more energy per gram compared to carbohydrates, so they are efficient for long-term storage. Finally, nucleic acids, DNA and RNA. DNA stores the genetic code and RNA helps in protein synthesis. These molecules control heredity and all cellular processes. Without nucleic acids, life is not possible. Now let's see some applications of organic chemistry. First, fuels. Petrol, diesel, LPG, kerosene, all are organic compounds. They are the main sources of energy in transport and homes. Second, medicines. Organic chemistry has given us drugs like aspirin, paracetamol, and antibiotics. These compounds save lives every day. Third, the food industry. Organic compounds are used as preservatives to protect food, as flavors to improve taste, and as artificial colors. Fourth, industrial applications. Plastics like PVC, fibers like nylon and polyester, dyes for coloring, explosives like TNT, and detergents all are products of organic chemistry. So students, in this session we studied important named reactions, polymers, biomolecules, and applications of organic chemistry. With this, our entire organic chemistry chapter is complete. We started from basics, went through hydrocarbons, benzene, functional groups, and today we finished with named reactions and applications. Remember, organic chemistry is not just a subject, it is connected to life, industry, and technology. That's all for today. Jai Hind.